According to the National Electrical Code, specifically Article 300.4F, terminating a flexible metal conduit, or FMC, or a liquid-type flexible metal conduit, or LFMC, through a blank stainless steel plate does not comply with current code requirements. The code stipulates that all terminations of flexible metal conduits must be made using a fitting designed for that specific purpose. In this scenario, the blank stainless steel plate isn't a fitting, and therefore does not meet the code's demand. To elaborate, let's delve into the reasons why such a termination is non-compliant and the implications of not adhering to these codes. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines governing the safe installation of electrical wiring and equipment. Its primary goal is to safeguard people and property from electrical hazards. Article 300 covers wiring methods in general, focusing on protection and installation of conductors. Section 300.4 specifically addresses protection against physical damage. Subsection 300.4F extends this protection to flexible metal conduits, mandating proper fittings for terminations. A fitting, in the context of electrical wiring, is a component designed to connect conduit to enclosures, boxes, or other equipment while providing mechanical support, electrical continuity, and protection against environmental factors like moisture and corrosion. Fittings ensure a secure and reliable connection that maintains the integrity of the wiring system. Firstly, mechanical integrity is crucial. Terminating a flexible metal conduit through a blank stainless steel plate lacks the mechanical strength and support provided by a proper fitting. A fitting is designed to grip the conduit securely, preventing it from being pulled out or damaged due to vibration, movement, or accidental impact. Without this secure connection, the conductors inside the conduit are at risk of being exposed or damaged, which could lead to electrical faults, short circuits, or even fires. Secondly, electrical continuity is also crucial. Fittings ensure continuous electrical grounding throughout the wiring system. Flexible metal conduits are often used as equipment grounding conductors, providing a path for fault current to return to the source and trip a circuit breaker or ground fault circuit interrupter, or GFCI. A proper fitting maintains this electrical continuity, ensuring that the grounding path remains intact. A blank stainless steel plate, on the other hand, might not provide a reliable electrical connection, especially if it is not properly bonded to the conduit and the enclosure. This can compromise the effectiveness of the grounding system, increasing the risk of electrical shock in the event of a fault. Thirdly, environmental protection is important. Fittings are designed to provide protection against environmental factors such as moisture, dust, and corrosion. Depending on the type of fitting, it can be liquid-tight, dust-tight, or corrosion-resistant, preventing these elements from entering the conduit and damaging the conductors. A blank stainless steel plate does not offer this level of protection. Moisture or dust can penetrate the conduit through the opening, leading to corrosion or insulation breakdown, which can cause electrical faults and reduce the lifespan of the wiring system. Liquid-type flexible metal conduit, or LFMC, requires special liquid-type fittings to maintain its water-resistant properties. Terminating LFMC through a blank stainless steel plate would completely negate this protection, rendering the conduit vulnerable to water damage. Furthermore, using an improper termination method can lead to several potential problems. Damage to conductors can occur because the sharp edges of the opening in the stainless steel plate can damage the insulation of the conductors as they pass through, especially if the hole is not properly deburred or smoothed. This can cause short circuits or ground faults over time. Loosening of connections can occur because the conduit can become loose over time due to vibration or movement, especially if it is not securely fastened to the plate. This can lead to intermittent electrical problems or a complete loss of power. Non-compliance with inspections can occur because electrical inspectors are trained to look for proper wiring methods and terminations. A termination through a blank stainless steel plate would be immediately flagged as a violation of the National Electrical Code, requiring correction before the installation can be approved. Safety hazards can occur because improper terminations can create safety hazards for people who come into contact with the electrical system. Exposed conductors or a compromised grounding system can increase the risk of electric shock or electrocution. In addition to the specific requirements of Article 300.4F, other sections of the National Electrical Code also support the use of proper fittings. Article 314 covers outlet boxes, device boxes, pull boxes, and junction boxes, which are commonly used in conjunction with flexible metal conduits. This article emphasizes the importance of using approved fittings to connect conduits to these boxes, ensuring a secure and reliable connection. Article 350 covers flexible metal conduit in detail, including the types of fittings that are permitted for use with this type of conduit. It specifies that fittings must be listed and identified for use with flexible metal conduit, and that they must be installed in accordance with the manufacturer's instructions. Article 356 covers liquid-tight flexible metal conduit, providing similar requirements for fittings used with this type of conduit. It emphasizes the need for liquid-tight fittings to maintain the water-resistant properties of the conduit. Article 250 covers grounding and bonding, which is essential for electrical safety. This article requires that all metal conduits and enclosures be properly grounded and bonded to ensure a low impedance path for fault current. Proper fittings play a crucial role in maintaining this grounding path. Firstly, to ensure compliance with the National Electrical Code, it is essential to use the correct type of fitting for the specific application. There are many different types of fittings available, each designed for a particular purpose. Secondly, some of the most common types of fittings for flexible metal conduit include straight connectors, which connect the conduit to a box or enclosure in a straight line. Angle connectors, which connect the conduit to a box or enclosure at an angle, typically 90 degrees or 45 degrees. Thirdly, swivel connectors, which allow the conduit to rotate or swivel, providing flexibility in tight spaces. Fourthly, liquid-tight connectors, which provide a watertight seal, preventing moisture from entering the conduit. Fifthly, grounding bushings, which provide a means of grounding the conduit to the box or enclosure. The selection of the appropriate fitting depends on several factors, including the type of conduit being used, the environment in which the conduit is being installed, and the specific requirements of the application. For example, if the conduit is being installed in a wet location, a liquid-tight fitting would be necessary to prevent water from entering the conduit. If the conduit is being used as an equipment grounding conductor, a grounding bushing would be required to ensure proper grounding. Once the appropriate fitting has been selected, it is important to install it correctly. The manufacturer's instructions should be followed carefully to ensure a secure and reliable connection. In general, the installation process involves the following steps. Firstly, cutting the conduit to the proper length using a conduit cutter or hacksaw. Secondly, deburring the cut end of the conduit to remove any sharp edges. Thirdly, inserting the conduit into the fitting, making sure that it is fully seated. Fourthly, tightening the fitting using a wrench or plier. Fifthly, inspecting the connection to ensure that it is secure and that there are no gaps or loose parts. In cases where existing terminations are found to be non-compliant, they should be corrected as soon as possible to prevent potential safety hazards. This may involve removing the blank stainless steel plate and replacing it with a proper fitting. If the conductors have been damaged, they should be repaired or replaced as well. In addition to the technical aspects of proper terminations, it is also important to consider the legal and regulatory implications of non-compliance with the National Electrical Code. Electrical installations that do not meet the code requirements can be subject to fines, penalties, and even legal action. Insurance companies may also refuse to cover damages caused by non-compliant installations. Therefore, it is essential to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the National Electrical Code and other applicable regulations. In conclusion, terminating flexible metal conduit through a blank stainless steel plate is a clear violation of the National Electrical Code, specifically Article 300.4F. The code mandates the use of proper fittings to ensure mechanical integrity, electrical continuity, and environmental protection. Using a blank stainless steel plate in place of a fitting compromises these critical aspects of the wiring system, increasing the risk of electrical faults, safety hazards, and non-compliance with inspections. To ensure a safe and compliant electrical installation, always use the correct type of fitting for the specific application and follow the manufacturer's instructions carefully. Consult with a qualified electrician if you have any questions or concerns about proper wiring methods and terminations. By adhering to these guidelines, you can protect yourself, your property, and others from the dangers of electricity.